Okay, we are getting started on a new little tool for me today. This tool is going to be built on top of the PE cough generator we already wrote. And I don't think it's going to be too hard to build this. It's probably going to take 2 or 3 sessions. The idea is I know how to generate a PE cough file. So I should be able to create a file with a symbol in it and point it at some data. And I should be able to pack in the data that I want. So in theory, I should be able to generate an object file that I can link to that contains any data that I'd like to bake into my program without having to turn it into a C header or switch to a language that has like a bake style file include. So let's see. I'm going to need a name for this little tool. Sort of a basic OBJ baker. Binary pack symbol. There you go. Include what if I call it raw symbol? So the command could be like raw sim. Um, Maybe something like that. Be even better if I could do this. Hmm. This would make it harder because I'd have to open the object file, modify it, and put it back. I think the easier way to do this for now make the list that way. The sucky thing about that is if you want to have a lot of shaders, it becomes annoying. What if I get aggressive and just do this? Okay. Okay. So raw sim is a fine name. You know what? Boom. Can never remember which order those two come in. Yeah, probably like this then. None of those apply. That applies. That applies. Call it asked what code editor is that? This is 4Coder. Okay. Gotta set up some new build lines here. Let's see. When you say it looks very hacky, what do you mean? Like it's all hardcore hacker looking, or hacky like uh, like a cheap? Source obj from raw slash obj from raw main.c obj from raw. Cool. Okay, so that builds. Gotcha. Yeah. Well, I'll be 100% honest. That's why the text is green. Black background, green text was my aesthetic choice because exactly what you're saying. Okay, the run script is going to need a little update now. OBJ from raw. Render. OGL render vshader.glsl. Alright, this is going to be a little bit of a pain. Okay, unpack colors is going to be the hard part here. Float VC0 no, sorry, C00 equals float parenthesis VC0 bit shifted by 0 and OXFFU divided by 255.0. 1, 2, and 3, 8, 16, and 24. Color 1. Okay. Okay, so that's a good starting sample of what I'm dealing with here. Now, okay, so hopefully that can be set up to work. Okay, nothing happens. There we go. Or I could do it this way. There's our executable. There's the input path to the GLSL file, and there's the output flag that goes with it. Now, command line arguments. We want to get a command line. We need an arena, and there are the args. Let's get an arena set up here. Print straight list dump. Okay, great. So you can see my command input structurer has identified this as an input file, this as a flag, and that as a parameter to that flag. So that's good. Now, What do these actually mean? Params from string. What you could do with the params once you have them? Or is this a part of the implementation? Might be that. Okay, so the goal now is to build a sort of data structure for describing the main bake here. Okay. All right, so now I've got an input data file. The question is, can I open it? Okay. How does that look? Hmm. It's kind of like this. No. It should be like this, right? Like, that should be less than that. Right, that's incrementing now. Okay. So we've got ourselves a name. Now what we have to do is we create one of these symbol nodes. Queue it up on our linked list here. Symbol. There we go. Just to be sure it's all living on this arena, I'll push a copy of the name. Okay. So after that is done, what we have now symbol list from arguments or from command line. Oh, let's see here. I'm feeling like a change of music today. You know, what would fit is this one. Okay, so symbol list is ready to go. Determine output file name. So each input creates one of those. We need to pull out the out flag for the output file name. All right, so we're looking for the string parameter attached to the out flag. Let's make sure that's doing what we think. Great, okay. Now, where's my PE gen? Here it is. Oof, okay. This part's going to be a little tricky because a lot of PE gen stuff has not been separated out from the core PE gen main file yet. In other words, I don't know if I'm set up to treat this code as reusable just yet. But I guess that's what we're going to work on next. Ugh. Okay. Basically everything here except for the main function seems connected. What if we did this? Cool. Okay, let's see if that works. I should be able to come over here and drop this and this. To make that. Right, you won't be able to find those because those are in binary /PE. Okay. Let's see. Let's see. Um, yeah. Okay. Now let's see if I can make any more of this code reusable. Main doesn't look too big here. I mean, it's got some code in it, but it's not that bad. Ideally, I could boil this all the way down to something like You know, I'm not sure. Let's just assemble this out of what we've got here. Now, I want to see. Yeah, a line right here that's like. Here's the beginning of the object file generator. Timestamp. We definitely need this much. We don't need the unwind info. No, no, no. 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 Yes. Okay, so for each symbol that we have in this list, we're going to do a loop. Okay, we create a block. Okay, now we got to get the data from the symbol. That's the data we want to drop into the data block here. Section list. One, two, three, four, 5, 6, 7, 8, 9. So we can't do that long. We do this long. 8. Hey, thanks for the subscription. I appreciate it. Contains initialized data. Block. There we go. Okay, so I set up a block, I've set up a section. What else do I have to do? I don't need any cough relocations. Don't need to set an entry point. I do want to set up a symbol. Symbol table. Symbol name. I believe we want storage class external. So we got the name, storage class, symbol type. Okay. So symbol type is just going to be 0 in this case. And then what else do we got? Position, right? We need the position where the symbol actually exists. So we need to make a label for that. So I got to give it the block. And then I have to give it the offset. There we go. Alright, I've been at it for about an hour, so now is probably a good time to do a quick little 5-minute break. Let's do that. Bigger, 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 perfect. Okay, be back in 5 minutes. Alrighty. List name flags v-size is the part I skipped. Symbol. Symbol. Okay. So we have a symbol name. We have a position. That should do it. Section list, patch list. We actually didn't end up using any patches. Yeah, now show me what I can do with obj-config. We don't really need that. We also don't really need this. Even better. Okay, so what reason I'm still here looking at this is I'm not quite sure how to finish the file now. I'm trying to make sure I didn't skip anything. Bake symbol table. I have to bake the symbol table and attach it to the obj-config at some point. Ah, there it is. We do need a patch list. obj header bake. Yeah, so this part right here could almost be its own function, except that it kind of depends on if it's an object file or not. In this one regard. Yeah. Okay. Let's just go for it for now. There we go. Okay, interesting. So I want to track down. Did we generate OGL render shaders.obj exists? Does bin dash work well enough? I bet it doesn't right now. Let's go and open up bin dash stage. This version? Ooh, this one's definitely not good. Okay. Here we go. The OG version from the jam. Does that work? Alright, first let's test it. Does it work on this? Okay, that looks pretty good. Then does it work on OGL render shaders? Cough header. One section. Okay, section table. We have .rdata $S. That's right. That's what we put there. Okay. OGL render vshader. Section 1 offset 0. And here's the R data. Great. So what we're missing now, that we can't see in the bin dash yet, OGL render shaders, open. There, you can see all of that. There's my GLSL shader. Brilliant. Okay. Okay, so let's mess around a little bit now. So we're building an object file with a symbol name and the data from our GLSL shader. But the real test is, can we link it? OGL build OGL render shaders. That OBJ. Right, and so one of the annoying things is that these no longer work. We'll have to go like this. Okay, so it's linking, but we didn't actually cut it off from its old way of working, so that's not impressive yet. What we want to do next is take our GLSL V-shader out of the picture and replace it with what did we end up calling it? OGL render V-shader. OGL render V-shader. See how that turns out. Okay, it built that. It built my bin dash with our GLSL V-shader removed. But I don't have it set up to run bin dash. When I hit F2, project F4, do I have I reload my project here. Right, so run fly will tell us that when we run bin dash, we actually have to change to a different folder. We can't run from the default folder here. // data / bin dash and // Mr. Forth / build load that project. F3 again. Didn't work, huh? What are we missing? Why not? Back, data, bin dash. That looks good. And then back, Mr. Forth build. That looks good. Bin dash .exe. Yeah, I think that should work, but it's not working, so I don't know what that's about. Just run from here and see what happens. Great. So the rendering is working. So what that says to me then is I should be able to extend this idea. So render shaders.obj. No, that's not what I want. You go away. I'm looking for render OpenGL OGL impl. You can go away. OGL render fshader .glsl. We grab all of this. I'm going to zero this out. Okay. New lines can go away. String quotes can go away. vshader, uniform, in, out. 1, 2, There's no macros or anything else in there. Okay. Okay. So then I should be able to just add the fshader file to the list here. Run that. And then build bin dash again. And yes, we need to switch to OGL render fshader. Boom. Very good. Take this out, put this in. Ah. Shader errors, line 97. Okay. Something's not quite right. Semicolon. Out equals. What's the difference? I'm not sure. Well, let's make sure that the object file looks correct. Make sure that part isn't the issue. They're not exactly the same size. They're not confused about where they belong on the file. We've got the two symbols. Separate sections, yeah. This looks fine. So you know, I do have one suspicion of what could be going on here, which is maybe it's not nil terminating like it should. Check this out. If I go in there and look at OGL render shaders, this one right? There's no guarantee that when we lay this out in a R data section that it's actually going to maintain that alignment. Let's look at what happens. So the linking is working. Let's look at what happens in the new bin dash executable itself. Bin dash.exe will have an R data section. And among other things that our data section should contain... Yeah, but I don't know where it is. That's the hard part. Yeah, there's just no way to know. Okay, let's do this another way. No, let's do imhex. Yep, use that pattern there. Oh, it didn't parse properly? Well, it's a real exe file, so it's not my fault. Eh. Okay. That's lame. Our data. Can I tell it to put a section header right here, please? No. It doesn't do anything for me. Does it need to like parse successfully before it'll let me do that? I don't even know where I would write that. Like, well, let me put that right here. Section header. Like, if it's got a parsing error, it's not going to do anything anyways, right? Like, it's too bad. Okay, so Virtual size, virtual offset, size of pointer to raw data. So 1, 2, 3, 4. Here's the name. 1, 2, 3, 4. So it looks like, if I've done it right, 74000 should be the right spot. Okay, there's our data. Somewhere in here, I expect to find the GLSL. Gotta be in here somewhere. Okay, let's try this. Can I search for the string version? There it is. We can see at the end of that one, we get some null terminators. We can see at the end of this one, new line 17, and there's this. That's not a null terminator, right? So I think the lesson is, if I'm putting in raw data, sometimes I might want the option to also put in a null terminator. Now, there's a way I can do that. By going like this, actually, data equals size plus 1. Oops, now F2 is running that guy. Build it, run it, build again, run that. There we go. Okay. So Okay, now I want to be able to specify certain variables for each input, and that's going to make things trickier because my command line system here I'm going to have to look through the nodes one by one. And determine which ones are flags and which ones are inputs. Okay. If the node params equals 0, then it's an input. We treat it exactly like this, except we get the input string now from node string. Now, if we're in the case where the node's params is not null, these all operate on the basis of finding the first match. So let me see real quick. If I not you. Okay. So we have a flag called N. My question is, if I were to put down like that, gotta figure out what that means. That's weird. Gives each of those a separate name. Cool. But why does that affect? Okay. One, two, three. The symbols come out just fine. Oh, it does that twice? Well, that explains it. This block is dead. Perfect. Okay. Okay. Okay, so I should be able to go capital N to set up a null terminator. Default that to 0. Okay, so right now, if I run this, cool, it works. So now the OBJ from raw has this null terminator option. Should be able also to show that it's working by doing something like taking that out. Running it, building again, and running again. That should have busted. Why doesn't it bust? I mean, the only way for it to bust is if it accidentally happens to be exactly set up with the without a null terminator when it links, which is not guaranteed to happen. Hmm. But this was busted a minute ago. That rebuilds both. That runs OBJ from raw, right? So then when I rebuild again, it should have relinked this with the new render shaders, but it's still built. It runs fine now. And if I go to imhex here, and I open my bin-exe, yes. For some reason it doesn't actually parse in imhex anymore, but if I go find version, we find a null terminator there. Yeah, that's not null terminated. I feel like that should be causing an error, but it's not. Which is weird. Okay, but I can at least test that everything's working. So, no null terminator. You know what's probably happening? These aren't intentionally valid ASCII, but the parser is happy to consume both of those as ASCII and then that as a null terminator. Let's run it again, but with the null terminator option. Okay, that built it. That ran this. That builds this again. And now I should be able to reload this. It didn't add anything there. Okay, here we go. Add null terminator becomes true. Look at the next input. Two two four two, 2243. Final data dot string 2243. Right, and this doesn't go past 512. So instead I'll do two two four zero, 2241, 2242. Yeah, that seems like a null terminator. Two 2995. Two 2990, 2991, 2992, 2993, 2994. There's our null terminator again. Okay. So why don't I see a null terminator here? It's weird. That's got a null terminator right there. That's got a null terminator right there. A0090. Wait a minute. That is a null terminator for sure. So maybe this isn't nonsense? I mean, maybe that's not actually supposed to fit this pattern of what's underneath it. Maybe that's a fluke. Maybe that is an ASCII new line and a null terminator. Yeah, I don't know where that came from. I must have... Hopefully I didn't accidentally modify the file. But if I save it like that, and then I run it... Yeah. And then So I've rebuilt the object file. Let's reload it. Render shader. Run it. Bin dash OGL render shaders. So there we go. Now it ends there with no null terminator. That one's ending with a null terminator, but this one's ending without one. Weird. Okay. Okay, there I've definitely made it garbage. Now it's definitely busted. This is the end of the file. There's no null terminator. And then it's just wrong. So what's going on in here where I'm not getting the null terminator? That's still confusing to me. It says, yes, add a null terminator. Let me also make sure I'm not confusing myself. Yeah, this is adding the null terminator as well. Yeah, it could be that the linker thinks that it can truncate nulls, but that would be pretty surprising. I don't think it should be shrinking away null data. You know what? Now that I say that, I think that sounds ridiculous. It shouldn't be allowed to do that. There's our V shader. It's got an attached null terminator. Add null terminator is still true. We load another file. We get another symbol with the name OGL render F shader with a null terminator. And with the output file name. Now we take each symbol. The symbol data here contains a null terminator. So that blocks own total size. Yeah. $2,993. Wait a second. Weird. Okay, so that is not null terminated. Okay, let's look at this more closely. Freaking debugger, okay. There, you see that? That should be null terminated. We are doing add a null terminator, so it's something about how I'm trying to add the null terminator that isn't working. Now there's a chance that the problem here yeah. So data.string. So well, hold on. Data is 29. Data.string plus 2990. Show me the next 10 bytes. Look at that. There's no null terminator. So I was under the assumption here this whole time that this OS file read would do us the courtesy of putting a null terminator there by default. But I bet you it doesn't. We get the total size. And we allocate exactly that many bytes, not an extra byte for a null terminator. So, two possible solutions. Either I make my core library say that when you load a file, it puts a null terminator there just in case. Another option is I copy the whole block into another block of the same size plus one and manually add a null terminator just to be safe. Kind of annoying. Another option is I take the block as is. Here's the easiest option probably. I'll mark the symbol for whether it has a null terminator or not. And when we go to create the block, if the symbol has a null terminator, we'll just use the PEGen API, which has the ability to take a block. And we'll push onto our block one extra byte. And then we'll fill it. That'll do it. Great. We build, we run, we build again, we run again. Yeah, okay. And now this goes 7G and then null terminator, and then that shows up. Whatever that thing is. So that's good. Now the null terminator feature actually works. Okay, well, I spent a couple hours on this today. Yeah, so I would say there's a good question in the chat, which is, should this mean that the core library should just add the null terminator optionally? And I would go farther. I would say maybe the best thing to do, a lot of my other stuff, like if you look at push F, how do I implement push F? Well, the point is it takes in an arena and a format string and generates, expands the format string into a full string on the arena. And push FV, if we take a look, is set up to take the actual size, which is how big the thing needs to be, and ensure that there's an extra byte there, so that when we fill, there's guaranteed to be a null terminator 1 at the end there, right? The final size is whatever comes out of this. That has to be 1 less than... That has to be no greater than actual size, which means there's an extra null byte at the end of the fixed buffer that you see here. You can see here when we're determining how much to pop, we also subtract 1 from this. Reason being we want to leave an extra for the null terminator. Another place where we might be able to see this is if we look at like OS file path. Some of these, I think someone said one of these has a problem. You know, push copy is a good example. That's nice and simple. Right here, you can see we are ensuring that there's a null terminator at the end. So whenever I have an API that allocates a string, even though I return it with a size, I pretty much always put a null terminator on it, which is why I was assuming that my OS file read did that too. Now you're asking, should it be optional? And my answer is maybe not. Maybe it should be always required, because we are returning a string from an arena allocation API. And so right here we have the opportunity to just throw in 1 extra byte on every file so that any of them that need to be null terminated are. And I don't think that that's a huge price to pay. And I'm a little surprised I didn't do it that way, because how I usually do it. All it would take would be to do this, right? Because the buffer will be filled to 0. If I wanted to, I could say buffer no fill, and then if we succeeded, buffer total size equals 0, right? Okay, so if we do that, then instead of doing the block push right here, and instead of marking this as a null terminator, we can just go back to final data equals the data. If we are adding a null terminator, then the final data dot size plus equals 1. And that should do just as well. Run, build again. Run. Very good. So, anyways, we've been at it for a couple of hours. What I've got so far is I can run OBJ from raw and feed in files, and it'll load those files if it can and turn each one into a symbol based on the name of the file. So what I don't have is I don't have features like changing the name of a symbol, right? If I wanted to, I might want to say like name R. Let's see, what might I call it? OGL render impl. I might call it something like, okay, let's call this RGLSLV shader, and let's call this one name RGLSLF shader. Right, and now it's kind of getting annoying that they don't line up, but we could even go like, okay, let's specify symbols like this maybe? Like, I don't know. Having it as a separate file input has some advantages. But you can see what I mean. We could imagine wanting to change the name of the symbol. Another feature that I don't have that I might want is right now, the way this is typing, the way I'm typing this is I'm saying there's a symbol, which is a string, and I have a pointer to it. The way symbols link is a little confusing. So you might think of it as we have a pointer to this character buffer, right? But actually, in order to link it, I just make it a character. It makes global variables are kind of pointer, are hid under the hood. It's actually a pointer to some memory location, but it's a pointer you can't change. That's why it's a global variable. It's a pointer that gets resolved entirely at link time, so that all the references to it are baked into the code rather than being an actual variable that you can change over time. So the next thing I could do is say, well, this is cool, but I don't know the size, right? I have a null terminator, which I need because I'm passing this to an API that's going to require a null terminated C string, but it doesn't look like a C string. It looks like a character. And so that's a little funky, right? I could say, you know what? Let's be a little more let's treat this a little bit more like a C type and go like OGL render vshader size, and then have a way of exporting things like a size symbol and a pointer symbol. It would add in like an extra 8 or 12 or 16 bytes, because these now have to link to a pointer which points to the block of data instead of linking to the beginning of the block of data. We could also pull this off by doing a trick like we could say those are our externs right there, and this will be an address of render vshader or something like that. We could even go a step further and be like, no. This is like this. And then have an OPL byte that needs to link, and make this size by going first byte minus OPL byte, or actually flip that. Right, we could do stuff like this so that now we can start to generate, it's not just a symbol that happens to have the right name to point at the right spot, and then you gotta funky around with the C-type system to make it make sense. Instead, the idea would be like, what if we have several different ways to attach symbols to these data blocks, and we want to be able to configure those. Haven't thought through how that would work. Haven't thought through if I want the header files that need to line up with that to be generated as well. But these are things we could be explored next with this project. So I want to spend a little time on this again. So maybe expect Friday and maybe next Monday or next Wednesday as well. We'll spend a week or so on this, but it's kind of already working. This was the tool I wanted to build, and the basic concept is up and running. There's also, let's not forget, massive opportunity for improvements to this program by improving the PEGen layer itself, which has not really undergone a production pass. But as a prototype for a tool, this looks like it's in good shape. I'd love to make it to the point where I've got a library version of this so that you don't have to run an executable, but you can just write your own program that generates the data however you want. So these data blocks don't have to be from files anymore. They could just be whatever name and data block you'd like to pack in. All sorts of additional steps to explore. But that's it for today. I'm going to sign off, and I'll see you all around the internet. Bye.